Hello students, in the previous class we discussed about the tape corrections, right? Now I am going to revise once again what are the different tape corrections and we will solve some numerical problems on this topic, right? So now in tape, okay, in chaining, right? So we have tape, okay? So for that tape we will have encounter some errors while doing the measurements, that is because of the absolute length, okay? So for absolute length, if there is any change in the length, expansion and contraction, then we will have pull or tension. We have correction for temperature. We have correction for sag. We have correction for slope. We have correction for alignment. We have correction for MSL, mean sea level. So we will come across what is mean by MSL in the leveling unit. Okay. So next, for correction for absolute length, we have a formula CA is equals to L into C by L. Then we have correction for temperature, that is CT is equals to alpha Tm minus T naught or T alpha into L. Okay. Next we have correction for pull or tension, that is Cp is equals to P minus P naught into L divided by AE. Right. Next we have correction for sag, that is CS is equals to LW square divided by 24N square into T square. Then we have slope correction for slope correction, right? That is H square by 2L, right? Next we have correction for horizontal alignment, that is CH is equals to D square by 2L, D square by 2L. Then this is the another side, okay? So broken base everything. So finally we have come to this. Last one is reduction to mean sea level. This is given by LH by R. LH by R. Okay. Now we will see the numerical problem on this. Okay. So the problem is given like this. A line was measured with a steel tape which was exactly 30 meters. It was exactly 30 meters. That means the L is equals to how much? 30 meters. Then at a temperature of 20 degrees centigrade, that means T naught is equals to 20 degrees Celsius, right? At a pull of 10 kg, P naught is equals to 10 kg, okay? The measured length was, right, 1650 meters, okay? L dash is equals to 1650 meters, okay? Now the temperature during the measurement is 30 centigrade, okay? So Tm is equals to 30 degrees centigrade, and pull applied was Pm. During measurement it was 15 kg. How much? 15 kg. Find the true length of the line if the cross section area of the tape was A, the point A, okay, capital A, cross section area of the tape is 0.025 centimeter square. Then the coefficient expansion of the tape is, that is alpha is equals to 3.5 into 10 power minus 6, okay. Then modulus of velocity, that is capital E is equals to 2.1 into 10 power 6 kg per centimeter square. This is the data given, okay. We have a tape exactly having 30 meters length, and that 30 meters length was at 20 degrees centigrade with a normal pull of 10 kgs. But by using this tape we are measured a length of 1650 meters, okay. Doing this measurement, he told that the temperature was 30 degrees. It is normally it is 20, but here temperature increased by 10 degrees centigrade. Then we applied a pull of, right, 15 kg. Normally it is 10 kg. Then for that, here area of cross section of tape is 0.025 centimeter square, and for alpha, right, coefficient of expansion of material is 3.5 into 10 power minus 6. And elastic modulus, right, that is 2.1 into 10 power 6 kg per centimeter square. This is the data given by the thing, but we have to know what is the true length. Okay, by combining both correction for temperature and correction for pull, we have to find out two things. One is correction for pull, another one is correction for temperature. By combining these two things, we will get final what is the exact value of this measured length. Okay, out of 1650, whether it is increased or decreased, we will find out what is the correct thing. Okay, now correction for temperature, right? So correction for temperature, Ct is equals to, what is our formula? Alpha into Tm minus T naught into L, right? So you can observe the formula for the correction of temperature. You can see here Ct is equals to alpha into Tm minus T alpha T naught into L, where here L is the measured length, right? L is the measured length, alpha is the coefficient of thermal expansion, and also Tm is the temperature at the during the measurement, T alpha is the temperature at the standard. Okay, so in our problem, if you are substituting all those values, right, here we have alpha value is how much? Alpha value this 3.5 into 10 power minus 6, 3.5 into 10 power minus 6. Tm during the measurement, what is the temperature? It was given as 30 degrees. Okay, now we will substitute here 30 degrees minus during the standard, what is the P naught value? That is, sorry, temperature. During temperature is 20, right? That's why standard temperature is 20 degrees. Then what is the measured length here? 1650. How much? 1650. Okay, so after calculating all these things, finally you will get a value of this 0.05775. Okay, this is the correction for temperature. Okay, please note it down. You can calculate. Finally, you will get this value. Please use your calculator. Okay. Next, correction for pull. Okay, correction for pull. Right. So correction for pull, and that means Cp is given by. We'll see what is the formula. Okay. Then only we will understand. Okay. Here Cp is equals to P minus P naught into L divided by A into E. Okay, that's why here, and also see what is the terms. P is the pull applied during the measurement, that is standard one. Here they gave 10, and P naught value, here they give 15. So P naught is the standard pull. Okay, P naught is equals to standard pull. In problem it is 10. This value is 15. Then L is the measured length, that is 1650. Then A, area of the tape they gave, and E is the Young's modulus. Area of the cross section of the tape should be in centimeter square, and this value should be in Newton per centimeter square. But other values are in their own calculations, right? So since it is in a centimeter, it will get cancelled. Okay. Now coming to the problem. Now we can see what is the pull applied during the measurement. What is the pull? That is Pm. It is pull applied during the standard into L divided by A into E. Okay. So here this is equals to what is the Pm. Okay. Pull applied during the measurement was how much? Here they gave 15 kg. Right. During the standard it was 10 kg. Right. That's why here what is we have to write 15 minus 10. Right. 15 minus 10 into 1650 divided by what is the area given? Area they gave of 0.025 centimeter square. 0.025 centimeter square into what is the E value? 2.1 into 10 power 6 kg per centimeter square. Okay. Substitute 2.1 into 10 power 6 Newton per centimeter square. After giving this correction, you will get a value of this. Okay, 0.157101 meter. You will get the answer. Okay, so here what the thing is, already we told that temperature is more, okay? Tm is greater than T naught, okay? If Tm is greater than T naught, you can refer here, okay? If Tm is greater than T naught, okay? The temperature during the measurement is greater than standard temperature, okay? So the correction is additive. Additive means we will have to put the positive, and also here P is greater than P naught, okay? 15 is greater than 10 during the case of pull. So if that is the thing, the correction is additive. That means we have to give the positive sign, okay? That's why in the problem, right, in the first case for the temperature, since Tm is greater than T naught, right, 30 is greater than 20 naught, that's why the correction is positive, we have to add. Then correction for pull, here Pm is greater than P naught, that's why it is also positive. So finally for true length of the line, what you have to do, you have to add all these values to the original value, right? What is the original value? 1650 plus, what is the value here? 0.057, okay, 5775, okay, 5775. This is correction for temperature. Then what is this value of pull? It is 0.157101, okay. So by adding all these values, we are going to get finally 160.214 meters. Okay. Finally, first of all, you can substitute values for correction for temperature. Then we will get value of 0.05775. Since Tm is greater than T naught, okay, it is positive. Then for correction of pull, right, we calculated and we arrived at a value of 0.157101 meter. It is also P naught is greater, Pm is greater than P naught, that's why it is positive. So finally the true length of the line is 1650 plus 0.05775 plus 0.15, what is called 7101, okay, 7101 we added to it, and finally we arrived at a value of 1650.214 meters. This is the true length of the line, okay. Next, second problem. We will see second problem. Here, the downhill end of a 30 meter tape held 90 centimeters too low. Okay. What is the horizontal distance measured? Right? What is the horizontal length thing measured? But downhill means how it look like? This is the downhill. This is the hill now. Downhill. Okay. So a downhill end of a 30 meters shape, okay, held, okay, 90 centimeters too low, okay. So then he is asking what is the horizontal distance measured, right? What is this distance measured horizontally? What is the distance measured horizontally? Okay. So for this it is a slope now, so we have to do the correction for slope. Correction for slope. Okay. So what is the formula for correction for slope? We will go and see again. Okay. Here it is h square by 2l. Okay. H square by 2l. Okay. Now by coming into the problem, what is the thing? H here, h is 90 centimeters. Okay. So that is equal to 0.9 meters. Okay. So then what do we have to write? 2 into L, right? What is the L? Length of the chain, that is 30 meters. Okay. Now we can substitute here. So for this thing is h square by 2l. So what is the h value? 0.9 square divided by 2 into 30. So finally I arrived at a point of 0.0135. Since it will be too long, no, right? So we have to subtract. Okay. That's why L minus correction. L minus correction. So finally we will get a 30 minus 0.0 135. We are subtracting that, we will get a value of 29.9865 meters. This is the problem for correction for a slope. Okay. Next, a 100 meter length, right? A 100 meter tape L is equals to 100 meter was suspended between under two ends under a pull of, what is the pull here applied? 200 newtons. Okay. The weight of the tape is W is equals to 30 newtons. Find the correct distance between the tape ends. Okay. So there two ends are there. Here they made a tape like this. It is due to a sag, due to weight. It is having some downward deflection. No? So due to this, okay, always what is it? We have to subtract that value. Why? Because much length will come compared to actual length, we will get a bigger length. Okay. So actual, what is the thing? Correction for sag we have to do. Okay. Now, what is the formula for correction for sag? We'll see. This is right here. Tape correction per length is given by L. L means length of tape, total length of the tape. W square is the weight, right? 24 into n square. N is the number of equal spans and P is the pull applied. Okay, pull applied. Okay. Now, coming to the problem, here you can write correction for sag. CS is equals to, okay. So what is the formula? L into W square divided by 24 into n square into P square. Okay. So what is the tape length given here? Tape length is 100 meters. Okay. 100 meters into what is the weight? Weight is 30 newtons square divided by 24 into number of span is only one span, right? So it is 1 square into what is the pull applied? 200 newtons into square, right? Into square. After doing that, we finally will get a value of 0.09375. Okay. So this, from this value has to subtract from the 100 meters. Okay. Since it is more length now, we have to deduct 100 minus 0.09375 meters. So finally we will get a value of 98.90625 meters as the correct distance between two tape ends. Okay. Then coming to the another problem, it is based on the correction for mean sea level. Okay. So correction for the mean sea level is given by the CS is equals to, MSL is given by, okay, LH by R. LH by R. Okay. What is mean by LH? L is the length measured, right? If you are taking a thing, no, from center of the earth, this is the radius of earth, right? So H is the, what is the height above the MSL and what is the length measured. Okay. Those are the values. Here he is telling that it is a elevation of 200 meters above. MSL is given 2500 meters. L is equals to how much? L is equals to 2500 meters. And what is the elevation? H is equals to 200 meters. Okay. And also radius of earth is given as R is equals to 6370 kilometers. 6370 kilometers. Okay. Now we can substitute here. What is the L? L is the 2500. Okay. That is in meters. Okay. So we will convert into finally kilometers into meters. No. Then H is the 200 divided by how much? 6370 into 10 power 3. Finally we will get a value of 0.0785 meters. This is the total correction for MSL. Okay. So these are the problems on tape corrections. Okay, please practice again, go rewind the video and you can see the how we solved the problems. Okay, this is most important from the first unit. So maximum you will get a problems based on this. Okay, so based on these 4 models you will get a problems. Okay, next we are having another topic called incorrect chain in surveying. What is the error and correction? What is the error and correction? Here also in case of tape we may have some corrections like that. We are also having corrections for chain also. Okay, so now the thing is here chain will have some fixed thing. Okay, fixed length 20 meters or 30 meters, but in some cases it may be less or it may be more. Even due to some error it may become 20.4 meters or sometimes it may become 19.5 meters. So whatever may be the reason, finally we find out what is the error with help of some fixed reference. No, we are going to check what is its accuracy, what is its correctness. Okay, so we saw that this is the values. Then already we did some work previously, again we need to apply this type of correction. Okay, so here if the chain that is employed for measuring length is not equal to the true length, then the length is measured won't be correct. If using a 20 meter chain to measure some distance, if we found that the chain the chain or tape is having some error, okay, even it may be more length or it may be less length is having, so that thing is not correct, but we need to go for the correction for that particular readings. Okay, a chain that is very long, if you are measuring a 100 meters length, for example I am taking 100 meters length, by using a chain is having 20.4 meters. I don't know, I assume that the chain is 20 meters, but because of that error it became 20.4. If we are using 20.4 meters chain, if you are measuring a 100 meters length of line, okay, what is going to happen? If this is more, okay, I am assuming that it is 20, but it is having very high value. Finally what value I will get? I will get more value. So then distance will become very less. Instead of getting 5 now, I will complete with some 4 point something within that length I will complete. Okay, that is, if the chain is very long, gives a distance lesser in value. I won't get 100 meter, I will get less than 100 meter. Okay, suppose that's why this means the error is negative. I need to add, right? So correction is positive. I need to add some more distance to to arrive at 100 meters. Okay, so now error is negative, I need to add. Take it as a correction positive. Okay, next second case. If I am taking 19.5 meters chain, I am assuming that it is 20. I don't know whether it is correct or not, but later I found that it is a 19.5 meters. If you are using 19.5 meters chain to measure a 100 meters length, how much value you will get? Right, you will get more value since it is very smaller one, right? So that's why a chain is short, it gives a larger distance value. In this case, the error is positive and the correction is negative. Here, chain is too long, now we need to add the value. If chain is too small, we have to deduct the value. Just keep in that mind. Okay. Now we will see before going to formulas, we are going to see. Okay, with help of chain, this can be used to measure length. We can use to measure area. We can use to measure volume. Right. So here we are going to take some values, that is true length. That is L is the true length or designated length of a chain or a tape. Okay. L dash is the incorrect one. Even it may be greater than 20 or less than 20. According to situation you will take, but L is equals to 20. If I am taking 20 meters chain, this is 20. Then the corrections for length, area and volume can be, we will see here, right? So here the correction for measured length, corrected area, L is equals to wrong length divided by, right? So L dash, what is the actually, this is designated length. Okay, this is error chain length, this is actual length. Okay, this is error length, and finally I am going to arrive with what is the exact length. Okay, so that's why true length of chain is equal, line is equals to measured length, that is L dash I measured with help of a some, what is called, having some tape which is having some error. Okay, now otherwise we can use, okay, in the vice versa, that symbol are different but formula is, okay, similar. Okay, now correction for the area, right? So here correction for the area will get true area is equals to measured area, capital A is equals to A dash into square root of L dash by L to square. Okay, so we have some other different thing here. Here we are going to substitute L dash by L is equals to, how L dash will come? So L dash is the wrong, right? Actually L is the original and the difference is L, it may be plus or minus. Okay, this will be substituted by L dash will be substituted by this value. Finally we are going to get 1 plus dl by L. Okay, now dl is the error. Okay, let dl by dl is equals to E, we are assuming as a E, then it become 1 plus E. Okay, this is 1 plus E, therefore 1 plus E into 1 plus E, if we are substituting that area. So finally we are going to get arriving a final thing called, by doing this we will get a 1 plus 2E into A dash. Okay, now correction for volume. Correction for volume, V is equals to V dash into L dash by, since it is a volume it will be cube. For area it is square. Okay, so for length is as usual. Okay, so now we saw that L is equals to L dash into small L dash by L, area is equal to, very simple, capital A into L dash by L into square. For volume, V dash divided by L dash by L in cube. Okay, 1, 2, 3. So now we will see the problem here. The first problem based on length. Okay, so here the chain found to be 250 meters. Okay, we will measure and we decide that it is a 250. Calculate the true length of the line if the length was measured with a tape of 30-meter chain and it was found 10 cm too long. Okay, now I am going to arrive a thing. L dash is equal to how much? 250 meters. The actual length measured L dash is equal, this is wrong value, this is not correct. Okay, so L dash is equal to 250 meters. So I am using a chain. Okay, I am using a chain that is 30 meters, but it is having error value of too long. Too long means 30.10 meter, because it is centimeters, 10 centimeters, 0.1 meter. That's why it will become 30.10 meter. Okay, now I can substitute in the equation capital A, true length of line L is equals to L dash into L dash by L. Okay, so that is equals to, what is L dash? That is 250 divided by 30.10 divided by, correct length is 30. Okay, so this is point. Okay, finally we will get a value in terms of meters. Okay, please calculate and find out the answer. Okay, now I am going to calculate another second thing. Okay, the length of chain was 30 meters in the beginning and 30.10 at the end of the work. Here we need to do the average, right? Average of L dash, that is 30 at beginning plus at the end I have 30.10 divided by 2, so I will get 30.05 meters. Now I will substitute in the same formula this value. L is equal to L dash into L dash by L, that is equals to 250 into how much L dash? 30.05 divided by 30. I will get final answer. Okay, now next, this is the problem for area. Area of the field was to be 4000 meters square when measured with a tape of 20 meter length. Okay, here they gave A value A dash value is how much? 4000 meter square, and the chain length was small is equal to 20 meters, but it was too short. Too short means very less. So L dash is equal to how much then? 19.9 meters. 19.9 meters. Then what is the correct area? So to determine correct area, we have a formula. Capital A is equal to A dash into L dash by L square. Okay, please remember square. So what is the A dash? 4000 meter square. L dash is 19.9 divided by what is the actual thing? 20. So finally we will get a value of 3960.1 meter square. Okay. Next, another problem for the volume. Calculations. There they found that V dash is equals to 5000 meter cube. Okay. So with the help of a tape of 30 meter. Okay. Tape is how much? 30 meter. But the tape was 0.5 meters too long. That means, L dash is equals to 30 point how much? 15. Okay. 30.15 meter. Then we have a formula to determine this. L dash by L cube. Here volume na cube. That's why it will become 5000 into L dash is how much? 30.15 divided by 30 cube. Okay. So finally we will get a value of 5075 meter cube by after doing this thing. Okay. So you can take this formula slowly by using calculator. Practice it. Okay. This is most important problems in this unit. Okay. So in the today's class we discussed the problems on numerical problems on tape corrections, and as well as we saw the what is the corrections for chain and tape. Okay. So if you are encountered a error and how we are going to do the correct values. Here we saw the correction for length, correction for area, correction for volume, and also we solved 3 different problems for all 3 cases. Okay. Thank you.